Welcome back. This is going to be part 2 of section 3.3 notes on quadratic functions. So we're going to start back with number 10. That's where we left off. So we're going to do some word problems and just analyzing a graph right here to finish up the section. So number 10 is asking you to analyze the graph to address the following questions about quadratic functions. All right, so I'm going to just put the answers down here. I'm going to write them down. So part A says, is the leading coefficient positive or negative? So remember, when you look at a graph, if it's going backwards, then it's going to be a negative coefficient at the beginning. Okay. B says, what is the value of H and what is the value of K? So remember, that's the vertex. So H would be -1. K will be 4. Okay, that's the vertex. C, what is the value of the leading coefficient? So we have to work that out. Okay, so we're going to do y equals a times x minus h squared, just like we did on part 1. We're going to substitute these numbers in for hk and those in for x and y. Okay, so we can find a. So y is 3. Don't know a. X is negative. Sorry, x is 0. X is 0 minus h, which is -1. So minus a negative is going to make that +1. And then k is 4. All right, so let's solve that like we did on part 1. 1 squared, 0 plus 1 is 1. 1 squared is 1. Okay. So 1a is just a, and we're going to subtract the 4 over here, so we get -1. So there's your value of a. All right, so now it says, write the equation of the function in standard, well, this should say, sorry about that, that should say vertex form. And then we're going to write the equation of the function in, and this is standard form. Typo. Okay. All right, so D is easy. Vertex form is just y equals whatever a is, and then x plus the vertex, which is +1 + 4. Okay? Remember, always use the opposite sign for x, the same for the k value. All right, then part E, we're going to take this and multiply it out. Like we did in part 1. Again, we did that several times. So first step is to FOIL. So I'm going to go ahead and FOIL that out. That FOILs out to x squared plus 2x plus 1. Now multiplied through by -1. So it changes all your signs. Then you're going to add those last two terms. So -1 plus 4 is 3. Okay. And again, you could write f of x here, you can write f of x there. Okay? All right, so that's a good question. It kind of answers everything we've gone over that was in part 1. So now we're going to look at some word problems. Okay? Now, keep in mind, you can use your calculator to graph these and find the answers. I'll kind of show you how that is. I'm going to do these just using the formulas just to get you used to that. So, number 11 says, a toy rocket is launched with initial velocity of 44.1 meters per second from a 1 meter tall platform. The height of the object, which is going to be h, at any given time, which is t, after it's launched, is given by this function. We have two questions. How long after launch did it take for the rocket to reach its maximum height? And then what is the maximum height? So first off, I just want you to think about what this looks like. So here's our xy axis. Remember that this number at the end of standard form is the y-intercept. So I know that's where the graph crosses the y-axis at 1. And obviously if you shoot the rocket into the air, it's going to go up for a little while and then it's going to finally come down and hit the ground, right? So this right here is the vertex. This is when it hits the ground, and this is where it was launched from. So remember, the y-axis is the height, and the x-axis is the time. Right? That's what it told us here. All right, so this question is saying how long after launch did it take for the rocket to reach its height? So that's here. So that's the time. So that's the x value of the vertex. And then this question says, what is the height? Well, that would be the y value of the vertex, right? So yes, it's time and height, but think about it in terms of x and y, right? That's what we're used to doing. So if you're going to do this on a calculator, you would change these t's to x's, because the t value, that's the x value. Time is always the horizontal axis. And then how high it got depends on the time. So after 1 second, you could plug 1 in here, figure out how high it was. After 2 seconds, you could plug 2 in there, figure out how high it was. All right, so our question is how long? So we need the x value of the vertex. So remember, the x value of the vertex is negative b over 2a. Okay, so here's our function. So a is negative 4.9 and b is 44.1. So we're going to do the opposite of b, negative 44.1 over 2 times a, which is negative 4.9. Okay, so just do that in your calculator. Negative 44.1 divided by, now be real careful when you do divided by, you got to do this first. So we're going to put that in parentheses, 2 times negative 4.9. If you don't put it in parentheses, you're going to divide 44.1 by 2 first and take that answer times that. That's going to give you the wrong answer. So you may want to do this first, just on your own. Okay, so that, I'm going to hit enter. That's one way to do it, 4.5. Or what I like to say is just go ahead and do the bottom first on your calculator. 2 times negative 4.9. Get that answer, 9.8. And then do this in your calculator so that you don't mess up. But either way is okay, just be careful with it. Okay? All right, so remember, these are seconds. So the time it took for the ball to get, or the rocket to get up to its maximum height was 4.5 seconds. Okay, now, what is the maximum height? So remember, to find the y value of the vertex, you're going to plug this into your function. So we're going to find h of 4.5. So that would be negative 4.9, 4.5 squared, plus 44.1 times 4.5, plus 1. And I would just put that in your calculator. Obviously, we're not going to do that by hand. Okay. So we're going to just as it is, negative 4.9, parentheses, 4.5 squared, plus 44.1 times 4.5, plus 1. So exactly like it's in written. So 100.225. And remember, this was in feet. So there's your vertex. So those of you that want to do it on your calculator, remember you're going to change these t's to x's, and then you could graph it, and then you could find the vertex. And that's perfectly okay with me. If you're going to do this on a test or a quiz, you would just need to draw this graph and say, I use my calculator, and tell me what you found for the vertex. I'm okay with that, but you do need to show me what you did. Okay? All right, last page. Another problem. You can do this on your calculator or by hand. So number 12 says that NASA launches a rocket at t equals 0 seconds, and its height in meters above sea level is given by this function. So the same thing, t is your x-axis, that's the time. H would be the y-axis, that's the height. Okay, so again, look at the y-intercept. So the rocket is being launched up here at 241 meters. So obviously it's up on its platform. So it's not launching from the ground. It's up 241 meters. It's going to launch and it's going to come down just like the toy rocket will. So here's your vertex. Here's where the rocket will hit the ground. So look at what you're asked for now. Assuming that the rocket will splash down in the ocean, at what time does splashdown occur? Well, splashdown is when it hits the water. That's this point, not the vertex. So it says at what time. So remember, time is your x and the height is your y, right? Okay, well if this is hitting the ground, the height automatically is 0, correct? That has to be true, right? As soon as it hits the ground, the height is 0. So I already know the h value is 0. So this is asking me what time. What time? So I got to solve this equation. So solving means finding t, or finding the roots, okay? So how many? You can graph, you can do the quadratic formula, okay? You can factor, which this one does not factor. So you choose the way that you want to do this. So let's graph this one and find the time, okay? Let's find that root. All right, so I'm going to go to y equals, and I'm going to put this function in here. Negative 4.9 x squared. Remember, you're changing that to x plus 319x plus 241. Now, most likely when I graph it, I'm not going to see too much of it, but let's see. All right, so I know this parabola is going up and it comes down, but it's way bigger than 10. Remember, your graph is set at 10 by 10. So this would be 10 seconds over here. So I'm going to have to go bigger than 10, and I'm going to have to go higher than 10 to see the height. So here's just a good trick. Now, I know some of you use Zoom Fit, but to me, Zoom Fit doesn't work all the time. So what I do is I go to the window. Now, I'm going to go back here for just a minute. I don't care about negative x or negative y because I'm looking in the first quadrant. So all I want to do is increase y max and x max, okay? And leave the other things alone. So I'm going to go to my window, and I like to just do this in increments of 10. So if 10 was not big enough for x max, then I'm going to change that to 100. I'm just going to go by powers of 10. And since y max, 10 wasn't big enough, I'm going to make that 100. And I'm just going to see what that looks like. All right, so x max is here. I see where it hits the ground. What I don't see is the vertex, which again is y max. So now I'm going to go back to my window, leave x max alone because that was fine. And now I'm going to change y max to 1000. Okay? Increments of powers of 10. Hit graph. Still don't see it. So I need the vertex, so I'm going to go back to window. Now, I can make this 10,000, which is probably going to be way too much, but that would be the next increment. So let's see, 10,000. All right, so see, that's all I need. I need to be able to see where it hits the ground, and I need to be able to see the vertex. All right, so I'm going to find where it hits the ground. That's a 0. So we're going to do second calc 2. And then I'm going to do left bound, which is anywhere to the left of this point over here. Now, even though those numbers are in the way, it's still there. Enter. And then we're going to do the right bound. Just make sure you go under there. Enter. And then guess. All right, so there's the time that it hits the ground or splashdown. 65.85. Well, we said 3 places, so 65.849 seconds, okay? Okay. So it takes 65.849 seconds for splashdown. Now again, if you don't want to graph it, you can do the quadratic formula. That would work just as well. All right, and then part B now says, how high above sea level does the rocket get? How high? Okay, so remember, this is time and height. So we need the y value of the vertex. So since we already have it in our calculator, let's go and find the vertex. Okay, so now we're going to go to second calc. And remember, the vertex is either a minimum or a maximum. So in this case, it is a maximum. So we're going to choose number 4. And we're going to do the same thing, left bound, right bound. So I'm going to use my left arrow, get back over here. Remember, you can't guess. You cannot just stick your cursor here and say, oh, it looks, this is a good point. Can't do that. You're going to get it wrong. So you go to the left of the vertex, hit enter. Go to the right of the vertex, hit enter. And then find the exact, it'll say maximum. We need this point. I don't care about the time. It took 32 seconds to get there, but we wanted the height. So 5,432.888, we'll call it. That is how high it got. 5,432.888. And these were meters. So that's how high it got. Okay? So there's a good example of one you might choose to do on your calculator. So again, if you were showing me the work, you would put, what you found for the vertex, you would put those ordered pairs there for me and show me that you used your calculator. All right, number 13, the last one. This one we're going to go back and do by hand. Suppose that you have 3,000 feet of fencing to construct a rectangular pen that borders a river. Okay? What should the length and the width of this fence be in order to maximize the area? And then what is the maximum area? Okay, so let's talk about, we have 3,000 feet of fencing. So remember, when you're putting up a fence, that is perimeter in math, right? The distance around. But this is asking you to find the area. So just so we remember, the perimeter of a rectangle would be to add up the sides. But we have a river over here, so we don't need a fence over here. Okay? So we just need the perimeter of this side, and this side. So let's call this side the width, and these are the lengths. They're the same. So to find the perimeter of this fencing that we need, it would be length plus width plus length, right? Just add up those sides, which is 2L plus W. The area for any rectangle is length times width, right? All right, so keep those in mind as we go through here. Now, typically the perimeter would be all 4 sides, but they were specific to say we have a river and we don't need a fence there. Okay? All right. So we are going to maximize the area. So the area is length times width. Okay? However, we can't use 2 variables in our calculator or to compute. We only need 1 variable here. So we're going to come over here, take your formula for perimeter, which was 2L plus W, okay, and use what they gave you. 3,000 feet of fencing. That would be the total perimeter. So that would be the 3,000. Oops, that's equals. Okay, so I know that I have 3,000 feet. So, am I going to do 1,000 feet here and then break up the rest? So you've got to figure out, well, how are you going to break up this 3,000 to get the maximum area? Well, that's hard to do in your head. So we're going to use a little algebra. So we're going to solve this for W. So I'm just going to move the 2L over. Okay. And now, in place of this W, I can put what L is, or what W is in terms of L. Okay, so I'm going to leave L there, and I'm going to replace this W with what W is equal to, which is 3,000 minus 2L. All right, so multiply that out. That's 3,000L minus 2L squared. All right, so again, you could change those to X's and you could graph that, okay? Or we could solve it using our vertex, because maximum area, remember, look at this graph, let me rewrite it. Negative 2L squared plus 3,000L. And I'm going to put plus 0. So now I've written it in standard form. The square term is first, then the L term, and then the number. So here's your A, B, and C. So this is a quadratic formula or quadratic equation, and since A is negative, I know it's going to do that. So again, the maximum area would be the vertex. So you could graph it and find the vertex, okay? So remember, this would be L, and then this side, the y value would be the area. So when you're looking at your ordered pair, sorry about that, your x value would be L, and then the y value would be the area. Okay, those are your two variables in here. So you would change these to x's, and then that would be your y equals. All right, or since we just want to find the length and the width, I could use the fact that x equals negative b over 2a. This is easy to do by hand, so negative 3,000 over 2 times negative 2, right? That's the a value. So that's negative 3,000 divided by negative 4, so that's 750. And remember, x is L, right? So the length is 750 feet, so you can now find the width. Okay. Where would you find the width? The width would be up here. I would take 3,000 minus 2 times L. Or you could kind of just think about it. If the lengths were 750, so you got 750 here you're using, 750 here you're using, which is 1,500. So how much is left out of the 3,000 would be another 1,500. Or if you can't see that, then you're just going to plug in 750 right here. Okay, so I'm going to do 3,000 minus 2 times 750, which will give you that 1,500. Okay, so there's your width. So there's the length, there's the width. Now, if you did this on your calculator, you're only going to get the length. You're going to get 750, so you still have to find the width, because it asks for the length and the width. Okay. All right, so now it's going to ask you for the maximum area. So again, if you did it on your calculator, you already have it. If you didn't do it on your calculator and you're doing it like I'm doing it, then remember the area is just length times width. So now you're going to just multiply these together. So 750 times 1,500. Okay, do that on your calculator. 750 times, oops. That 750 times 1,500. So we get 1,125,000. And this was square, what are we doing? Feet. So there would be the area. So this is one reason I don't like to do this one on the calculator, because look how big your numbers are. So you're going to have to change your window quite a bit. And it just takes a lot of time. So it's always good to know how to do this just using the negative b over 2a. It doesn't take that long. Okay. You will spend more time sometimes trying to find the graph on your calculator than you will if you had just done it this way. So I would say to practice this way, because you never know the questions you're going to be given on your homework or on a quiz or test. If the numbers are real big, it may take you way too long to do it on your calculator. Some of you are a little better at that than others, so that kind of is up to you. All right, so that takes care of this section. Let me know if you have any questions. Email me if there's any problems. Get to work on the homework if you haven't started already. It's due soon. And I'll see you back here next time.